unit. Okay, this is going back to complex number. Alisa, you have some experience with complex number?
Yeah.
You have that, right?
Yeah. And he helped me get a better understanding of it.
Okay, you already discussed that.
Some of it, yeah.
So what is the fourth root of unit? Okay, what is that? Okay, so this means tell me all the complex number so that when you multiply that complex number 4 times, you get 1. Just fourth root of. So what I mean by this, fourth root of 1, right? Now of course I know one. We know one answer. 1 and -1 is there, right?
Right.
But there are 2 other, which is I and -I. So in this case I have 4 answers. Not only 1 and -1, but you also have I and -I in the complex. So if I draw the picture, so on the unit circle means circle of radius 1. I have that 4 numbers, 1, I, -1, and -5. So you divide the unit circle into 4 equal parts. You divide the unit circle into 4 equal parts. Why 4? Because it's the fourth root of unit. And each one of them is a fourth root of unit. So this number, so the first number that comes after 1, the first one that comes after 1, this one, we denoted that by W. So in this case, I mean, it's not a standard notation, it's not universal notation. In this lecture, I call that W because we used that notation in the previous lecture. So what are the Fourier bases in this case? So what is that? Also an example. So the Fourier basis in this R4, Fourier basis in R4 is the following. This is going to be a. So I have to write. So how many? So in the basis, how many vector I should have in this basis? How many?
4.
4, right? So I need to write. If I want to write this in matrix form, I should give you a 4 by 4 matrix, right?
Mm-hmm.
So let's write that 4 by 4 matrix. So it's going to be 1 around the border in the top and on the left. So I have 1 here and 1 here. So I have 1 here and 1 here, and then I have this W. So then you write. So along this you write W. And then you just take this W squared, W cubed. The next one is going to be you move one exponent up. So what comes after W? W squared. And then you square this one, the previous. So the way you go down, right? So it's going to be W 2 times 2.
Oh.
Or W to the 4.
Oh,
Yep.
okay.
And then W to the power 2 times 3.
Oh, okay. So
Cube.
Oh, okay.
Okay.
If you want, and I can write this way, W squared if you want.
Is the next one going to be W to the 3rd power?
Exactly. So this is going to be W to the 3, and then you square. When you go down, it's W cubed is squared, and W cubed.
I'll try.
But in this example, in R4, W is simply
know.
I, right? We can just, in place of W, I can just simply write I, and you can simplify this.
Oh, yeah. Okay.
So in this example, in this case, actually W is actually equal to I. And we know that I squared is equal to what? -1.
-1.
So using that fact, you can simplify this. So this can be simplified. You can simplify this.
So W is a representation of I.
In this case, in
Okay.
R4, right?
Okay.
So in R4, it happens to be I. Let's look at next example. Let's look at R8.
Which is an 8 by
So
8
this
matrix.
this is a Fourier basis in R4. Yeah, in R8, what do you think in R8?
So in R8, it's just going to go W, W2, W3, W4, all the way up to W7, right?
Exactly. But what is W, first of all?
I.
In R4, W happens to be I. But R8,
I
what is
squared.
W?
I squared?
Well, let's
Which is
see.
1, right? -1, right?
Let's see. Yeah, I mean, well, let's see. So in R8, we have to talk about 8th root of unit, right?
Mm-hmm.
So in R8, we have to talk about 8th root of unit. 8th root of 1. Well, again, 1 and negative 1 is there. But that's not all. There are 6 other
Mm.
in the complex number.
Yeah.
Okay? And what are those? Well, instead of writing down, it's actually very easy to visualize in the complex plane. If you draw the complex plane, just like before, this 8th root of 1 is going to be equally spread around
So it's
on
like
the unit circle.
on the axis and then in between. Okay.
So in the unit circle, it's going to be equally spread around. So I need to divide this unit circle into 8 equal parts,
Mm.
and each one of them is 8th root of unit.
Okay.
So starting from 1 is there.
So it'd be 0 to 45,
Exactly.
90.
So can we think of this as like degrees?
Yeah. I mean,
Right.
these are.
But these are
That's
complex
another
numbers.
representation of complex number using the degree and the radius, right?
Mm-hmm.
So this is my 1, and this is the next one after 1, right? So
Mhm.
the first one that goes after 1, that's your W.
Mm.
Okay, the first root of unit that comes after 1
Counterclockwise.
is in counterclockwise is your W. This is, I mean, we can actually write it down. What is that? You know, this is in the representation of polar form. Maurice maybe explained that you later is e to the 2 pi. The whole thing is 2 pi. You
Mhm.
divide it into 8 part I, right? But this is the exponential form. But this angle here is, how much is this angle? Is 2 pi over 8, which is of course 45, right?
That notation comes from differential.
This one,
Mm-hmm.
yeah.
Mhm.
So well, you don't have, okay. So just e to the I x is cosine x plus I
Plus sine x. Right. I remember.
This is the Euler's formula.
Yeah.
So one way we can write this e to the ix in this form. This
Mhm.
way.
Which goes back into the unit circle because
circle.
yeah, because of
But
degrees.
don't worry too much. All you have to remember is just some complex number.
Mhm.
Some complex number. I can write down this a plus bi format if I want, right? Well, let's write it down in a plus bi format. So if this is 45 degree, what is my a and what is my b? Using trigonometry, right? So this is going to be cosine of this angle.
Mm-hmm.
So it's cosine 45 degree. And then this one is going to be sine
45 degrees.
45 degree. So if you want to write, so cosine 45 degree is, if I remember, is 1 over square root of 2.
Which is just too radical too when you rationalize it.
And then plus I, and this is my B, right? Sine
Mhm.
45 degree, which is again 1 over square root of 2. Okay, so that's my W in a plus bi format. But any complex number can be written a plus bi, right? Right?
Mm-hmm.
But a is the x coordinate and b is the y coordinate. And the matrix is going to be similar. So just have a practice one more time. For the R8, the Fourier basis, I have to give you 8 by 8 matrix. Right?
Yeah.
And then the first column, all 1, and then 1 here. And then you start with W. Your W is this complex number in
Mhm.
this case. That's your W. And then to go down is W square, W cube, all the way to W to the power 7. The next one is W square here, and then W
squared.
to the, so W square is square. Maybe that's, you can see the
Mhm.
pattern, right?
Mhm.
Which is W to the 4, of course. And then W square cube, all the way up to W square to the power 7. The next one is W cube, then W cube is square, all the way to W cube 7. The last one, this is how it goes. The last one is going to be W to the power 7. This is W to the power 7 is square, W to the power 7 to the power 7. Of course, this can be simplified using what actually your W is. You can substitute and simplify. Nothing we're doing it by hand, we're using computer, right? So this is just a, so that's the Fourier basis. Okay? And the reason it has advantage over the standard basis is that when you convert this to this basis, many of the coefficient is going to be close to 0.